So today we're going to learn the properties of equations. Now let's start this with situation. Oprah Winfrey, if you switch the names, could be written as Winfrey Oprah. Okay? Whether she signs this way or that way, it's still the same Oprah, right? Same person. So I put an equal sign. So that case, when you switch the left and the right and the right and the left, you call that commutative property. Look at my hands. That's commutative property. Now, we want to check if commutative property works in math. Okay? Will this property work with numbers? We will try it out with the four operations. With addition, subtraction, multiplication, and division, we will test it out first. Let's start if commutative property works for addition. Now, for any numbers a plus b, so if you reverse that, that will be b plus a, right? What do we mean by that? You simply reverse the position of a and b, okay? And that becomes b plus a. Will the answer be the same? Because it means equal. Let's put in some number. 12 and 4. So 12 is written first, but on the other side, 12 is written next. The other number is 4. Now 4 goes first. Does it matter? Some people would say that. Yes, on the left side it's 16. And on the right side, it is also 16, right? Therefore, does commutative property work for addition? Definitely. So that's a big check for us. It works for addition. Now, how about for subtraction? What do you think? Write something in the chat, write something in the message before we experiment on it. Okay, let's see if you're right. So for any number, if you reverse a minus b, is it the same with b minus a? Let's check. So if I have 12 minus 4, again, the 12 is here. It's switched on the other side. And then the 4 is the second number. Now it's switched as the first number. So the first answer will be an 8. 4 minus 12, is it also 8? You've learned integers already. It's going to be negative 8. Is positive 8 the same with negative 8? Definitely not. Look at the symbol I wrote, not equal. Therefore, does commutative property work for subtraction? So we definitely write a big X. That means no. Commutative doesn't work for subtraction. Let's try multiplication. Again, let's reverse the A and the B. So 12 goes there and the 4 goes there. They switch places. Left side is 48. The right side is also 48. Definitely that's okay. We put a check. Commutative property works for multiplication. Okay, how about division? So let's try let's switch the positions of A and B. Should be an A here, all right? So 12 divided by 4 is definitely a 3. But 4 divided by 12 will be 4 over 12, or the lowest terms is 1/3. Or you could make it a decimal, right? But are these two equal? Definitely not. So we could say what? Commutative property doesn't work for division. Okay. Now let's summarize. What have we learned so far? We learned so far that commutative property only works if you switch it. By the way, the answer is the same. And it only works for addition and multiplication. Do this. Commutative, follow my hand. Commutative only works for addition and multiplication. Again, commutative only works for addition and multiplication. All right, good job. That's the first property. Let's now move on to the second property. Now, check out this situation. Now, grandma would say, Be sure you make your bed, wash dishes, and clean the bathroom. And then this is you, and you will respond, right? Will you do all of it? But you cleaned the bathroom first, then washed the dishes, and then you made your bed. You did not follow the sequence stated by grandma. Now, make bed, wash dishes, clean bathroom. Is it equal to cleaning the bathroom first and then washing dishes and then making the bed? Does it matter? Did you accomplish the task? Does the order matter? Hmm? No. So you call that associative property. You associate, okay, whatever you want to do first as long as the result will be the same. Oh, will it work in math? Okay, and will this property work with numbers? So again, we will try it out with all the four operations. Let's start with associative for addition. Now, check this out. They're the same numbers, ABC, ABC. But the thing here is there is a parenthesis, meaning I have to do this first. Remember order of operations? PEMDAS, P represents parentheses. So let's plug in some numbers. So let's do the left side of the equation first. Let's do this. And then later on, we will do the right side and we will compare if they're the same. So in this case, do the parentheses first, you get a 24. All right, 24. Now, next, add the 23, add the 3. If you add the 3, we'll do that later. On the other side, add the 8 and 3 first, you're going to get an 11. Then bring down that 16. Okay. Now we're ready to add the left side. The left side is a 27. Think of it as a seesaw. Will it be a balance? All right. On the other side, 16 plus 11 is 27. 27 is the same with 27. Therefore, they are totally correct. They're equal. So whichever you do first, it doesn't matter. The answers will both be 27. So that's a big check. Associative property works for addition. Associative is like this. You associate with the parentheses. Okay, we're good. Now let's try it with subtraction. Again, all subtraction now. Let's do the first two. And then on the other side, let's do the last two first. Okay, let's do the left side first. 16 minus 8 is 8. All right, minus 4. Now, on the other side, if we do 8 minus 4, we're going to get 4. Then bring down the 6. It's going to be 16. Again, you're checking if the left side is it equal to the right side to know if they are totally balanced. 8 minus 4 is a 4. Okay. But on the right side, 16 minus 4 is a 12. Is that a true statement? If I do it this way, or if I do it that way, will my answers be the same? No. Again, you could say they're not equal. Therefore, that's a big cross. It doesn't work for subtraction. Now, how about multiplication? Does it work for multiplication? Check out, they're all multiplication. Let's do the left side first. The left side will give me 128 times 3. On the right side, do that first. The one with the parenthesis, 24 times 16. Okay? So again, we're checking if the left side will be equal to the right side. Okay? So 384. 384 also. All right. So whether you start with AB or you start with BC, it doesn't matter. Your answers are the same. It works, okay, for multiplication. A big check for you. How about division? All right, let's check division. Check out the signs. They're all division now. Let's put in the numbers again. So I get a 2 divided by 4. 16 divided by 2. On the left side, you get 2 over 4 is 1 half, right? But 16 over 2 is an 8. Therefore, this way, if you answer it this way, and on the other side you answer it that way, they're not going to be equal. Therefore, a big X for associative in division. Wow. So now, Let's proceed to our conclusion. Associative property only works any way you group them. Look at my hand. Any way you group them, you'll get the same answer. So it only works for addition and multiplication. Again, follow me. Associative. Say it. Associative only works for addition and multiplication. All right, that's the second property, associative. Now, let's move on to the third property. Now, this is a monkey. You groom the monkey, straighten the hair. What else? Put perfume and then cologne or something. Put some clothes, yeah? And he will look like this, right? So nice. Now, they're still equal, but they look different. Now, check this out. The shower, the grooming, the clothes did not make him into a human being. Whatever you do, it's still a monkey, all right? It will not be a human being. That means it retains its identity. When you say identity, that means yourself. I did not change. Okay, like people, right? No matter what factors or what people would influence them, they're not being bothered. They're the same self. You don't change. You retain your identity. Now, identity property. We want to know which number will retain the identity. Let's start, for example, 12. What numbers, when added, will result to still a 12? Oh, I thought adding makes it bigger. Yeah, but check this out. What number will I add to make the number still the same number? Type your answers. Let's check. All right, let's pause and then now the answers. Yes, what will you add? Definitely you just add nothing. All right. So what can you say? 0 is the identity property or identity element of addition. Just add 0, it's the same number. Next, how about the identity property of subtraction? What do I subtract to 12 to 450 to the fraction or to the decimal and the result is still the same? What will you subtract? Think, write in the chat. Okay, correct. The answer is, again, 0. Take away nothing. It's still the same number. So 0 again is the identity element for subtraction. Okay, ready? Next is multiplication. What will I multiply to these numbers and get the same number? Think. I thought multiplying makes it bigger. But no, I want it the same. All right, correct. The answer is 1. Multiply any number by 1, the answer is still the same number. See that? For multiplication, multiply it by 1, it's the same number. How about for division? Division. What will I divide with this number and the result is still the same number? Can you type it? Aha, this is challenging, huh? Think. Would it be a 1? No. Or a 0? No? Think. Okay. Correct. It's a 1. There you go. 1, 1, 1. Divide any number by 1, it's still the same number. Again, 1 is the identity element of division. So identity, same thing. Now, so identity property, what will make it the same number? Think it the same number, no change. So for addition and subtraction, use a 0. Okay? Add or subtract 0. But for multiplication and division, use 1. All right. Identity is the same self. Identity. And you use a 0 or a 1. The next property is this one. But let's look at this analogy first. All right. Too much alcohol and cigarette killed the man. This man multiplied by these substances brought him to death. Death, you could think of death as you're nothing now. You're not positive, you're negative, you're back to 0. Okay, so think of it. That's called the 0 property. What will make you 0? Okay, like you don't exist anymore. What will make it 0? Now let's check the following. What will I add to make these numbers 0? Think. All right? Yes, the correct answer is the opposite. Add the negative or the positive of the other number, you'll get a 0. So the opposite will be the 0 element for addition. All right. How about for subtraction? What do I subtract to this number and I'll get a 0? Think. Answer. Here we go. It's the same number. Okay. So the number itself would be the 0 element for subtraction. Subtract the same number, then you're back to 0. How about for multiplication? What do I multiply to get a 0? Wow. Correct. Multiply it by 0. All right. Again, now 0 is the 0 element for multiplication. How about division? Okay, divide everything by what number? And the answer is 0. This is the tricky one. Divide, it's not multiplying, huh? If I divide by 1, it will be the same number, right? If I divide by 0, 0 times 0, will it result to 12? No, right? So in that case, division has no 0 property. It cannot happen. Why? Because you cannot divide by 0. Division by 0, you will hear this all the time, is undefined. Undefined. Why? Because if I put a 0 here, check it out. If I have to multiply these two, my result should be a 12. Is that possible? No. 0 times 0 will not be a 12. So never ever divide by 0. It is undefined. So you could say, well, division has no 0 property. Okay. Now, 0 property, what did we say? What will make a number 0? In addition, add the opposite. In subtraction, subtract the same number. For multiplication, just multiply by 0. And for division, none. Just say undefined. Okay, remember that property. That's the fourth property now. Let's now move on to another property. Okay, now this is mom. Mom distributes her love to the children, right? Equal children. I give you my heart, little boy. I give you my heart, little girl. Nice of mom to distribute the love. And, you know, normally, regularly, that they're showing equal love, right? For some cases. Now, parents distribute their love to their children. And when you do that, you distribute. Distribute. Look at my hand. Distribute. Distributive. You give something to each of the person. Now, let's see if distributive property works for multiplication over addition. Is this one the same with that? Actually, these are two ways to solve this problem. Let's move on the left side first. Do the parentheses first, PEMDAS, you get a 7, right? 7 times 3 is 21. Okay, that's the regular way, PEMDAS. But you can now try to use distributive property. What do you mean by that? Distribute the 3 and distribute look at the 3. The 3 is distributed to 2. What else? The 3 is distributed to 5. See that? The 2 goes there. The 5 goes there. And 3 was distributed. So mentally, you could solve that as 6. You could solve this as 15. Then finally, you could add. Your answer is 21. Are they the same? Look at these two answers. Yes, they're the same. So that works. Distributive property works for multiplication over addition. How about distributive property of multiplication over subtraction? Again, let's do this one first. Parentheses first, you get a 5, right? 5 times 3 is 15. Now, let's work on the other side. Again, the 3 will be distributed. 3, look at this 3. 3 was distributed to 7. And 3 was also distributed to 2. There you go. All right, this is the 7. And this is the 2. Okay. Distributive. Some people will do this mentally on their mind. Okay. When you do this distributive. But anyway, that becomes 21 minus 6 and you get 15. Check it out. They are equal to each other. Again, thumbs up. It works. Same answer. Therefore, distributive property of multiplication over subtraction works. Now let's summarize. Distributive property works for two cases: multiplication over addition and multiplication over subtraction. Okay, so remember that. Next, another property, one last property. If you multiply a number by its reciprocal, you've heard this, remember when you're dividing, it is also called, another name for reciprocal is the multiplicative inverse. Remember that. Reciprocal and multiplicative inverse mean the same. The thing is, if you multiply a number by its reciprocal, the result is always 1. This is the representation using variables, A over B, B over A. So check it out. If I have 4 over 1 and multiply it by the reciprocal, look at my fingers, reciprocal, the 4 goes down and the 1 goes up, okay? You'll get 4 times 4, 4 times 1 is 4, 1 times 4 is 4, 4 over 4 is a 1. Yeah, it's a 1. How about the next one? 2/3 times the reciprocal, 3 halves, that becomes 2 times 3 is 6. At the bottom, 3 times 2 is 6. What is 6 over 6? Again, it's equal to 1. All right? So remember that. You call that inverse property. Inverse, you do the reciprocal. Inverse property of multiplication, and it results to a 1. Okay, now let's do practice time. So in this practice, you pause the video without the answers, and then once you're ready, play the video and check your answers. Ready? Here we go. Pause. Answers. You got it right? Good job. Pause. Remember, you distribute 6 times 5 and 6 times 3. 30 plus 18 is 48. That's the first example. Do the rest. 70, 40, 22, and 60. Got it right? Pause. Now you write the property just by looking at the equation. Use the letters on the left side. Okay, ready? Pause, and here are the answers. Okay, good job. Now you're identifying the properties. Be specific with it. Okay? Pause. Okay, here are the answers. All right, you got them all correct? If not, correct it. Good luck.